Let's analyze the complexity for Levenshtein distance problem for all these approaches one by one. In recursion, there are 3 available choices to perform at every recursive call. So the time complexity will be exponential, that's the 3 to the power m, where m is the length of the first string. Now space complexity. The algorithm is not taking any extra space apart from internal stack space, so counting that, it would be mn, as there are m cross n recursive call possible at a time. Now with top-down approach, we do eliminate all the duplicate recursive calls, so the recursion tree will left to be just of m cross n size, so the running time will be mn. And as we are using n2d array for memoization, the space complexity will also be m cross n. That's the extra space used by algorithm. Next, the bottom-up approach. In this approach, we are going through both of the given string to find the edit distance for all the smaller subproblems. So running time will be mn, and space complexity will also be m cross n, as we are storing LDS length for all the subproblems in the array. But this can be further optimized by observing that we only need the value of 3 adjacent cells in the table to find the value of the current cell, right? So you may try that solution.